All right, in 2-6, our topic is radical equations. So in this section, we will be talking about how to solve radical equations. And so, first of all, we get into what is a radical equation. So a radical equation is any equation in which a variable is in the radicand. That's a fancy way of saying under the root symbol. All right? And so in order to solve it, here's kind of some general steps. Isolate the radical, and then raise each side of the equation to whatever the power is to eliminate the radical. So if it's square root, you would square both sides. If it's third root, you would raise both sides to the third power. Fourth root, raise both sides to the fourth power, and so on. All right? Now, here's another key thing that we need to talk about before we even start trying to solve any of these. Raising each side of an equation to a power sometimes produces extraneous solutions, or solutions that do not satisfy the original equation. And so what that means is, really, anytime you either raise both sides of an equation to a power, or you're solving absolute value equations, those are the two main situations where extraneous solutions could get introduced. All right, so what that means is whenever you are solving equations with any of those two scenarios, the solutions that you get may not be solutions to the original equation. Those are the situations where you can introduce extraneous solutions, or solutions that may not be real answers. All right, so what are extraneous solutions, and what's an easy way to show why they exist? All right, so take, for example, this equation. X equals 5. All right, so 5 is a solution to this equation. If I put 5 in there, it's equal on both sides. Okay, now what happens if I were to square both sides of this equation? X squared equals to 25. All right, so when I square this now, the solutions to this equation are 5 and negative 5. Oops. 5 and negative 5. Okay? So 5 squared is 25. Negative 5 squared is 25. And so this negative 5, that is not a solution to the original equation. Okay? Negative 5 is not a solution to the original equation. That's not a solution to that. Okay? Negative 5 does not equal to 5. So again, when you raise both sides of an equation to a power, or if you're solving absolute value equations, okay, you have introduced the possibility of getting an extraneous solution. So what that means is anytime you're solving equations, when you're doing that, you've got to go back and check all the solutions that you get, because there may be some that you have to throw out that are not solutions to the original equation. All right, so let's do this one right here, for example. Okay, if I want to solve this one, well, the first thing I need to do is bring this 2 over here to the other side. We want to isolate the radical, so that's going to be 2x plus 2 equals to the square root of 100 minus 12x. Okay? Now at this point, I can actually square both sides. I want to square both sides of this equation. Okay? All right, so on this side, I'm going to get, let's see, can we do this without explicitly writing it out? I think we can. 2x times 2x is 4x squared. 2x times 2 is plus 4x. Now 2x times 2x is plus 4x, and then 2 times 2 is plus 4. And that's going to be equal on the other side. Square root squared just makes 100 minus 12x fall out of there. All right. Now, from here, how am I going to solve the rest of this thing? Well, it's just a regular quadratic from here. So I want to get all of the terms on one side, set it equal to 0, and solve it like I normally would. So that would be 4x squared. Can add these together and get plus 8x plus 4. I can go ahead and bring these two terms over, plus 12x minus 100. Remember, whatever comes across will change sign from what it was before, equals to 0. And clean this up a little bit, combine some like terms here. 8x plus 12x, well, that's 20x. And 4 minus 100, that's negative 96, equals to 0. Okay, so the next thing I'm going to do here is I'm going to pull a 4 out of here. That'll leave me with x squared plus 5x minus 24 equals to 0. So I factored a 4 out of there. Now I can factor these parentheses into a product of two binomials. So that's what we'll do next. X here, X here. And let's see, I'm looking for, let me get my sign straight first. The only way that I can get a negative is a positive times a negative, and since both of these are the same, both x's, I can go ahead and write them in. And so I need two numbers that multiply together to give me negative 24, but combine together in the middle to get a positive 5. So let's see. All right, what times what equals 24? We can go 6 times 4, but the problem is the difference of those two is not 5. So it can't be 6 times 4. 8 times 3 has a difference of 5. And how do I know which one is positive? Since my middle term is positive, the bigger one has to be positive. So I'll go 8 here, 3 here, I factored it. So what that means is my solutions to the equation are going to be negative 8 and 3. Now remember, in this step here, when I squared both sides, I created the possibility of introducing extraneous solutions. So one or more of these may not be a solution to the original equation. So how do we check it? The same way you would normally check any other equation. You got to take the answers and plug them in. So let's check negative 8. So I want to see if 2 times negative 8 equals the square root of 100 minus 12 times negative 8. I want to see if, minus 2. Okay, I want to see if they're equal. Well, over here we got negative 16. And underneath here we're going to have, let's see here, negative and negative is a positive, so that would be 196. And then that would be a minus 2. And so I believe that's 14. Let me just double check that because I'm not quite sure 100% here if that's the case. Let me go with, get my calculator out here, and I'll do 14 times 14 and see if that's true. So I got 14 times 14. It is 196. So subtract 2 from that, and that's going to leave me with 12. So negative 16 does not equal to 12. And so what that tells me is that negative 8 is not a solution. So I'm going to cross that one out. Negative 8 is not a solution. Let's see if 3 is a solution, because there's a possibility that none of these work. So I'll go 2 times 3 equals, 2 times 3 equals square root of 100 minus 12 times 3, and then minus 2. And let's see what we get. That'd be 6 is equal to, that's 100 minus times 12, 36. So that'd be square root of 64 minus 2. 6 is equal to 8 minus 2, which is 6, and that is a solution. All right? So 3 is your only solution to this equation. Okay? 3 is the only solution. Okay, we've got a couple more that we want to look at here. Okay, so on this next one, what I want to do here is I want to move the 14 over to the other side, so then I'll have the third root of x minus 5 squared equal to 15 minus 14 is 36. Okay, so now the next thing I want to do is I want to get rid of the radical here, so I'm going to raise both sides to the third power. So I'm going to raise this to the third power. I'm going to raise 36 to the third power. Now, when I do, x minus 5 squared drops out of there, and 36 to the third power is 46, 5, 50, whoops, 46, 656. Okay? All right. Now, the next thing that I can do here is I can take the square root of both sides here. So when I take the square root of both sides here, that's going to be x minus 5 is equal to plus or minus 216, because remember, when you take the square root of both sides, you introduce both of those in there. And then so this will be x equals to plus or minus 216 plus 5. And so that yields me the two solutions of 221 and negative 211. All right, so 216 plus 5, 221. Negative 216 plus 5 is 211. And so once again, I'm going to have to double check these to see if any of them are extraneous or not. In other words, if any of them do not work. Okay, so the first one, let's plug it in and see. I'll take the cube root of 221 minus 5 closed squared plus 14, and I want to see if that's equal to 50 or not. All right, so let's see. So underneath here we can go 221 minus 5. That's going to be 216, I believe. Am I right? Then I got 216 squared, right? And then, well, I need a calculator for this. They are trying to make me think too much. All right, let's see. So I can go 221 minus 5, all right, 216. So I can go 216 times 216. And then I need to take the cube root of that, which I already did here. I already know that that's 36, right? So we can go ahead and write 36 back there. And 36 plus 14 equals to 50. All right, so that's a good solution. What about the next one? Cube root of negative 211 minus 5 closed squared plus 14. We want to see if that is equal to 50. All right, so negative 211 minus 5, that's negative 216. 216 squared is back to 46, 656, which we know the cube root of that again is 36, plus 14 equals to 50 again. And so actually both of these are correct. None of them are extraneous. So there you go. All right, let's try one more example here. Now for this one, we have got ourselves two different radicals, and they're both on different sides of the equation. And so really, with this one, there's no real isolating method that we could do here that's going to help us out a whole lot. The only thing that we can really do here on this one is just go ahead and square both sides. So I'm going to square this side, and I'm also going to square this side. Okay? May get a little bit messy, but we can deal with it there. So when we square root this side, we've got x minus 2 that falls out. However, okay, when we square the other side, we can do 5 times 5, which is 25, right? Then it would be 5 times this radical, which is minus 5 square roots of 15 minus x, right? Minus another 5 square root of 15 minus x. Okay. And then if I multiply this times itself twice, that'll just kind of square itself out and make plus 15 minus x. Okay, so now I've got an equation that I'm going to have to do some simplifying to try to solve here. So on this side, we'll still stay with the x minus 2, but I can go ahead and put these two together because they're like terms. So now I've got 25 minus 10 square roots of 15 minus x plus 15 minus x. Okay, so I just added those two like terms together. 5 of these minus another 5 of these, negative 10 of these. All right, so let's see what we can do next here. I would say that we can now get all of our x's and regular numbers on the same side. And so when we do that, we can go x plus, whoops, bring the x over here. Minus x will become plus x. And we can go negative 2. I can combine those together right here and get 40, right? And then move the 40 over and make that minus 40. So we'll combine as much as we can as we go. Then I'm just left with negative 10 square root of 15 minus x. All right. Now I can combine like terms over here on the right-hand side and get 2x minus 42 is equal to negative 10 square roots of 15 minus x. Okay? Now, when we squared both sides in the first step, we got rid of one of the radicals because it was already isolated. Now we're getting to the point where we're trying to isolate this other radical here. And so now, in order to get rid of this other root that we're looking at here, I can now at this point square both sides again. Right? So I can square both sides again. And so on the first side, because now I want to get rid of this square root, right? So now 2x times 2x, 4x squared. Let me see here. So in the middle, we would get negative 84x minus 84x, which is negative 168x. Okay? And then I've got 42 squared, which is going to be plus 1764. And on the other side now, I've got this thing squared, right? So let's see, negative 10 times negative 10, that's going to be 100, right? And of course, this radical will square itself out, so that's still going to be 100 times 15 minus x, all right? So again, when I square this out, remember this is like negative 10 square roots of 15 minus x times negative 10 square root of 15 minus x. So negative 10 times negative 10 is 100. And then square root of 15 minus x times square root of 15 minus x. The square root part is gone, and this just drops out of it. All right? Now, what else can we do? Well, on this side, I can go 4x squared minus 168x plus 1764. I can go ahead and multiply this out and get 1500 minus 100x. Okay. Now I can subtract 1500 from both sides there, and I can, let's just go ahead and make this equal to 0. So I'll do 4x squared, negative 168x minus 100x. Over here will be plus 100x, so that would be minus 68x. If I subtract 1500 from this, that would be plus 264. Set them equal to 0. And so I'm getting closer here. Let's pull a 4 out. So that'll be 4, open a set, x squared minus, pull a 4 out of 68, 17, divide 264 by 466 equals to 0. Now I'm ready to factor into a product of two binomials here, and that's going to be x and x. And so my signs are going to be negative and negative. That's the only way I can get a positive at the end, and then a 17 here. Now, two numbers to multiply together to get 66, but at the same time they add up to 17. That would be negative 6 and negative 11. So negative 6 times negative 11, positive 66, negative 6x, minus 11x, negative 17x in the middle, and we're good. So that means my solutions are going to be x equals to 6 and x equals to 11. But are either of them extraneous? Let's find out. Okay, so let's plug in 6 first. So back to the original equation, that's going to be the square root of 6 minus 2, right, equals 5, open, 15 minus 6. Okay, so let's see if that works. And so that's going to be 4, well, excuse me, square root of 4, which is 2. And on this side, that's going to be the square root of 9, which is 3. And so that'd be 5, and I forgot to put a minus in between there. 5 minus 3, let's see, which is 2. So that checks out. So 6 is good. What about the next one? Square root of 11 minus 2. We're plugging 11 in here now. Equals to 5 minus square root of 15 minus 11. And so that's 3 equals 4, so that's 5 minus 2, which is 3. So 3 equals 3. That one also checks out. So both of these are good. Didn't have to get rid of any of them, but you've always got to check. All right, so look at that. Wasn't that fun? All right, see you in class.